Hey there, fellow space enthusiasts. Welcome to our deep dives, and today we're cracking open a classic astronomy text, astronomy.demystified.pdf.
Ah, yes. This one's great. It's really like having a personal tutor for the universe. It breaks everything down so well.
Yeah, it really does.
hmm
So we're not just going to be throwing out facts, we're going to be understanding them, right?
Exactly. We're building a foundation here, like understanding how everything connects in the grand scheme of the cosmos.
I'm all for building a strong foundation, and I think a great place to start is with celestial coordinates,
Yeah, definitely.
like our cosmic GPS, right?
Yeah.
But instead of latitude and longitude, we've got right ascension and declination,
Yeah.
and that's how we pinpoint stuff in the sky.
And the cool thing is you can actually use these coordinates on websites like Weather Underground, to map the sky from wherever you are.
Wait, really?
Yeah. It's like having your own personal star chart.
So I can use this book, go online, and actually know what I'm looking at when I look up at the stars.
Pretty much. It brings those constellations you see in the book to life, right in your own backyard.
Okay, hold on. I got to bookmark that website right now.
Eh.
Okay, I'm back. So tell me more about these celestial coordinates.
Well, they're also key to understanding how the positions of stars actually change based on your location and the time of year, too.
Oh, right, right.
For instance, think about the equinoxes.
When day and night are equal.
Exactly. During the equinoxes, the sun's declination is at 0 degrees, meaning it sits directly above the equator.
So the equinoxes are like these cosmic balancing points with the sun right in the middle.
You could say that.
Duh.
It shows just how interconnected Earth and the sun are, how they shape our seasons and how we view the sky.
That's pretty mind-blowing when you think about it.
Yeah.
Okay, so let's talk constellations themselves.
Mm.
I've always loved looking for patterns in the stars.
Me too.
And this book, it highlights some of the major ones like Virgo, Leo, Cancer. And I love how it uses simple visuals to show star brightness.
Yeah, it makes it easy, right?
Like brighter stars get bigger dots, which is super helpful when you're dealing with light pollution and you can't see everything.
It really helps bring the constellations to life, especially for beginners.
Totally.
Like take Virgo, for example. She's holding a staff of wheat, which makes her a bit easier to pick out.
Right.
And then there's Leo, the lion, which is supposed to look like the Sphinx.
It's amazing how ancient cultures saw these figures in the stars.
I know, right?
It's like they projected their own stories and beliefs onto the universe.
Exactly. It shows how we've always been fascinated by the night sky, trying to find meaning and order up there.
Speaking of finding meaning, let's talk about the moon.
Okay.
I was amazed to learn that we can actually see more than half of its surface.
Yeah.
How is that even possible? I thought we were stuck with just one side.
It's because of something called libration, which is basically the moon's wobble as it goes around Earth.
Okay.
This wobble lets us peek around the edges a bit, so we end up seeing about 59% of the moon's surface.
That's so cool, like bonus footage of the moon.
Yeah, exactly.
But what about those dark areas on the moon? I learned in school that they were seas, but I have a feeling that's not quite right.
You're right. They're actually called Maria, and they're huge plains of volcanic basalt.
Oh, wow.
Yeah, they formed billions of years ago. And, back then astronomers thought they were bodies of water, so they gave them names like the Sea of Tranquility.
I remember those names.
Yeah, it just shows how our understanding of the universe is constantly changing.
It makes you wonder what we'll figure out next.
For sure.
But before we move on to the sun, which I'm really excited to talk about,
Okay.
I have to ask, how did early astronomers figure out the moon's distance and size? Like, without any of the fancy technology we have today.
They were really clever, actually. They observed the moon from different points on Earth, and by measuring how its position seemed to shift against the background stars, they could calculate its distance.
Huh. So they were using geometry.
Exactly. It's called parallax. And once they knew the distance, they could work out the size using simple, angular measurements.
It's amazing what you can do with observation and a little bit of math.
Right.
Okay, let's move on to the big star of our solar system, the sun.
Yeah.
Now, I always assumed they figured out its distance using that same parallax method, but this book says differently.
Well, you're right. They couldn't use parallax for the sun because it's way too bright. So instead, they used a combination of Kepler's third law and measurements of Venus.
Okay, remind me, what's Kepler's third law again?
It basically says that there's a relationship between how long it takes a planet to orbit the sun and how far away it is.
Got it.
So, by measuring Venus at its furthest point from the sun, they could use some trigonometry to figure out the ratio between Venus's distance and the sun's
Oh,
distance.
that's pretty clever.
And then they could use that ratio and Kepler's third law to calculate the actual distances.
Now, that's some serious brain power at work.
Yeah.
But here's something else that blows my mind. This book says the sun's diameter is actually bigger than Earth's orbit.
I know, right?
It makes you realize just how massive the sun really is.
Yeah, it really puts things in perspective.
And speaking of amazing solar stuff, the book also explains solar eclipses.
Ooh, yeah, those are always cool.
I've heard the terms umbra and penumbra before, but I've never quite understood what they meant.
Well, the umbra is the area of total shadow where the sun is completely blocked by the moon. And the penumbra is the area of partial shadow.
So if you're in the umbra,
You see a total eclipse, and depending on where you are in the penumbra, you'll see a partial eclipse.
so it all comes down to location.
Exactly. It's like a cosmic shadow puppet show.
I like that. A cosmic shadow puppet show.
Yeah. And this book does a great job of explaining how those shadows work together to create the different phases of a solar eclipse.
All right, next stop on our tour of the solar system. The inner planets, Mercury and Venus.
Ooh, two very different worlds.
Yeah, they're both super close to the sun, but their climates are so extreme.
It's incredible, isn't it?
Mercury, being the smallest and closest, has insane temperature swings, like over 800 degrees Fahrenheit during the day and then plummeting to almost -300 at night.
Yeah, it's basically a cosmic sauna followed by a deep freeze.
Brr, no thanks.
Right. And then there's Venus.
Our sister planet in size, but definitely not in temperature.
Definitely not.
Yeah.
Venus is actually the hottest planet in our solar system.
Hotter than Mercury, even though it's farther away.
Yep. That's because of its runaway greenhouse effect.
Ah, right. The thick atmosphere is trapping all that heat.
Exactly. The surface temperature on Venus is hot enough to melt lead.
That's just terrifying.
Yeah, it really makes you appreciate Earth's relatively mild climate.
Seriously. I'm feeling very grateful for our atmosphere right now.
Me too.
Yeah.
And studying Venus helps us understand what could happen if we don't take care of our own planet.
Okay, time to journey to the red planet, Mars.
All right.
Now, this book talks about the possibility of seasons on Mars, similar to Earth's, but much longer.
That's right. Mars is tilted on its axis like Earth, but its year is almost twice as long as ours.
So a Martian summer could last for, like, half an Earth year.
Exactly. And Mars is home to Olympus Mons, the biggest volcano in the solar system.
Wait, hold on. A volcano on Mars, bigger than Mount Everest.
3 times taller, actually.
How is that even possible?
Well, Mars doesn't have plate tectonics like Earth, so volcanoes can just keep erupting in the same spot for billions of years.
Wow. So Mars has the longest seasons, and the biggest volcano. It's a planet of extremes.
It really is.
This book also talks about the mental challenges of traveling to Mars. It's not just the physical hardships, it's the psychological toll of being so far from home for so long.
Yeah, it's something we often overlook when we think about space travel.
Being cooped up in a spacecraft for years with the same small crew.
Exactly. It would take incredible mental strength to handle that.
I can only imagine. And speaking of Mars, I have a question about Phobos, one of its moons.
Okay, what about Phobos?
The book calls it Mars's doomed moon. What's going to happen to it? Is it going to explode?
Not explode, but it's definitely headed for a dramatic end.
Oh no, what's going to happen?
Well, its orbit is slowly decaying, so eventually it's either going to crash into Mars or get ripped apart by tidal forces and form a ring system around the planet.
Okay, that's definitely something I wouldn't want to be around for. Another thing that caught my attention was the idea of the butterfly effect on Mars.
Ah, yes. That's fascinating, isn't it?
So what does that mean? That butterflies are flapping their wings on Mars and causing chaos?
Not quite, haha. It's the idea that tiny events can have huge, unpredictable consequences, especially with weather patterns.
So a little change can snowball into something enormous.
Exactly. And because Mars has such a thin atmosphere, even small disturbances can trigger massive dust storms that cover the whole planet.
So a butterfly flaps its wings on one side of Mars, and the other side gets hit with a dust storm.
Well, not literally, but you get the idea.
It's incredible how connected everything is, even in the vastness of space.
Yeah, it really is.
Okay, so we've covered the inner planets, but what about the outer planets? Things get even weirder out there, right?
Absolutely.
The book mentions the challenge of defining a day on planets like Uranus because it's tilted on its side.
Yeah, Uranus is like the ultimate side sleeper. Its poles point almost directly at the sun for part of its orbit.
So how do you even measure a day when one side is in constant daylight for years?
Right. It's kind of meaningless to talk about a day based on the cycle of day and night. So astronomers use the planet's rotational period, which is a little less than 18 Earth hours.
So a Uranian day is measured by how fast the planet spins, not by the sun.
Exactly.
It's amazing how we have to adjust our thinking when we leave Earth.
Yeah, it really is.
And speaking of unique celestial bodies, there's one that always stirs up debate. Pluto.
Ah, yes, the little guy. That's not quite a planet anymore.
Is it a planet? Isn't it? This book dives right into that debate.
Yeah, it's a tricky one. You see, Pluto is small and has a really weird orbit, so it doesn't quite fit the definition of a planet.
So what is it then?
Well, the book talks about the different categories, and it suggests that Pluto might be better classified as a dwarf planet.
A dwarf planet. What's
Yeah.
that?
It's basically a celestial body that's big enough to be round because of its own gravity, but hasn't cleared its orbital path of other debris.
So it's like a planet, but not quite.
Exactly.
It's interesting how something so small can cause such a big debate.
It's because it challenges our understanding of what a planet is, you know?
Makes you wonder what other surprises are lurking out there in the universe.
Oh, I'm sure there are plenty.
Well, that's all the time we have for today. Join us next time as we continue our deep dive into astronomy.demystified.pdf.
See you then. Welcome back, space explorers. Last time we left off talking about pushing beyond our solar system into the realm of interstellar travel.
Yeah, it's mind-blowing to think about,
Totally. And this book gets into some really interesting concepts like time dilation.
Time dilation.
Yeah, it's part of Einstein's theory of relativity.
Oh, right, right.
Basically, as you approach the speed of light, time actually slows down for you relative to someone who's standing still.
So if I were on a spaceship traveling near the speed of light, I would age slower than people back on Earth.
Exactly. It's like a real-life time machine.
Sign me up. But before I pack my bags for a trip to Andromeda, the book also talks about some of the dangers of interstellar travel.
Right, yeah.
What are we talking about here? Space pirates? Giant space squids?
Haha. While those would make things interesting, the book focuses on more realistic dangers, like meteoroids, radiation, and of course the psychological challenges we talked about earlier.
Oh, right, right.
Even tiny particles can cause serious damage to a spacecraft at high speeds.
And then there's the radiation.
Yeah, that's a big one.
I know Earth's atmosphere protects us from a lot of the sun's radiation,
Mm-hmm.
but out in deep space,
Mm.
there's nothing to shield us, really.
Pretty much. Cosmic radiation is a constant concern on long space missions. It can increase the risk of cancer and other health problems.
But it's not just about building a fast spaceship. It's about protecting the crew, too.
Exactly. And shielding against radiation adds a lot of weight, which makes it harder to get the spacecraft going in the first place.
It's starting to sound like interstellar travel is a bit of a catch-22.
Kinda, yeah.
But the book doesn't just focus on the problems. It talks about solutions, too.
Oh, yeah.
It's like the idea of using telepresence and teleoperation to explore space without actually sending humans.
Right. That's super interesting stuff. Telepresence basically lets you experience space remotely through a robot.
So I could be sitting here on Earth controlling a robot on Mars.
Exactly. You could see through his eyes, feel the Martian soil, maybe even do some experiments.
That's amazing. It's like virtual reality, but for real.
Exactly.
But what about those of us who still dream of actually going to these distant worlds? Are we stuck with rockets forever?
Not necessarily. The book gets in some pretty wild theoretical propulsion systems.
Okay, like what?
Well, one of the most promising is nuclear fusion, which is the process that powers the sun.
Fusion power. That's pretty intense.
It is, and it could potentially allow us to travel much faster than we can today.
But even fusion has its limits, right? What if we want to travel to another galaxy?
That's where things get really speculative.
Okay, I'm intrigued. Tell me more.
The book mentions matter-antimatter engines.
Matter-antimatter.
Yeah, antimatter is basically the opposite of matter.
And when they meet,
They annihilate each other, releasing a massive amount of energy.
and we could use that energy to power a spaceship.
Theoretically, yes. It would allow us to travel at speeds close to the speed of light.
Wow. This sounds like something out of Star Trek.
It does, doesn't it? But there are a lot of challenges, like how do we produce and store enough antimatter? And how do we control that energy?
So matter-antimatter engines are probably a long way off.
Yeah, but you never know what the future holds.
That's true. We've already accomplished incredible things in space exploration.
Exactly. And this book shows just how much more there is to learn and discover.
So we've talked about the challenges of interstellar travel and some mind-blowing possibilities for the future. What else does this book have in store for us?
Well, next time we'll be diving into the tools and techniques astronomers use to study the universe, like telescopes, radio astronomy, and even astrophotography.
So we're going from space travel to space observation.
You got it. We'll be exploring how we see the universe beyond just visible light.
Okay, I'm ready to see the universe in a whole new light.
Great. Join us next time as we continue our deep dive into astronomy.demystified.pdf.
Welcome back, fellow space explorers. We're on the final leg of our deep dive into astronomy.demystified.pdf. And this time, we're shifting gears a bit.
Yeah, we're going from venturing out into space to understanding how we observe it from down here.
Exactly. We're going to be looking at the tools and techniques that astronomers use to unlock the secrets of the universe.
It's like we're going behind the scenes to see how the magic happens.
I love that. So let's start with the classic tool of astronomy, the telescope.
The OG of space exploration.
Right. I've always been fascinated by how telescopes let us see things that are so incredibly far away.
Yeah, it's mind-blowing when you think about it.
The book talks about refracting and reflecting telescopes. What's the difference between those? And is one better than the other?
Well, it's not really about one being better, they just have different strengths. Refracting telescopes, like the kind Galileo used, use lenses to bend and focus light.
Oh, so they're like a giant magnifying glass for the stars.
Exactly. They're great for looking at bright objects like the moon and planets.
Right. I remember using a small refracting telescope as a kid and being amazed by the craters on the moon.
Yeah, it's a classic first experience with astronomy.
Totally. But the book mentions something called chromatic aberration. What's that?
It's basically where different colors of light don't focus perfectly, so the image can look a bit blurry.
I see. So that's where reflecting telescopes come in.
Right. Reflecting telescopes use mirrors instead of lenses to gather and focus light.
And that avoids the chromatic aberration problem.
Exactly. Plus, mirrors can be made much larger than lenses.
So reflecting telescopes are better for viewing faint objects like galaxies.
You got it. They're like giant light buckets collecting as much light as possible from those distant objects.
That's incredible. It's amazing how we can use these simple concepts, lenses and mirrors, to unlock so much of the universe.
It really is. And speaking of unlocking the universe, this book also talks about telescope specifications.
Oh yeah, things like magnification and aperture, right?
Those are important factors.
But I'm not exactly sure what they mean.
Well, imagine your telescope is a window to the universe. Magnification is how much you're zooming in through that window. Aperture is the size of the window itself.
Okay, that makes sense.
A larger aperture lets in more light, which means you can see fainter objects.
So it's like having bigger, more powerful eyes for the cosmos.
Exactly.
But this book doesn't just stop at visible light. It takes us on a tour of the entire electromagnetic spectrum.
Right, from radio waves to gamma rays.
Why is it important to look beyond the light we can see with our eyes?
Because visible light is just a tiny part of the whole spectrum.
Oh, right.
It's like listening to a symphony and only hearing one instrument. Each part of the electromagnetic spectrum carries different information about the universe.
So we're getting a more complete picture by observing these invisible wavelengths.
Exactly. Radio waves, for example, can penetrate clouds of gas and dust.
Ah, so we can see things that are hidden from view in visible light.
Right. And infrared radiation lets us study the heat signatures of stars and planets.
So we can learn about their temperature and composition.
And then there are the high-energy wavelengths, like X-rays and gamma rays.
Those sound pretty intense. What do they tell us?
They come from the most extreme events in the universe. Things like black holes, supernovae, and active galactic nuclei.
So they're like cosmic fireworks.
Exactly. And we can detect them from billions of light years away.
That's just mind-boggling. It's amazing how we've been able to expand our vision beyond just what our eyes can see.
It really is a testament to human ingenuity. We've built incredible instruments like radio telescopes and X-ray observatories to observe these invisible realms.
And then there's astrophotography.
Ah, yes, the art of capturing the cosmos.
I've seen some stunning images online. How do astrophotographers capture those incredibly faint objects with so much detail and color?
It's all about long exposures and special filters.
So they're basically collecting starlight over long periods of time.
Exactly. And by combining multiple exposures and using filters, they can reveal details and colors that we wouldn't be able to see with the naked eye.
It's like painting with starlight.
It is. It's a beautiful blend of science and art.
Well, as we wrap up our deep dive into astronomy.demystified.pdf, I have to say this book has been an incredible journey.
I agree.
We've explored the basics, ventured to distant planets, pondered the possibility of alien life, and now we've seen how we observe the universe in all its glory.
And we've only just scratched the surface.
Exactly. There's so much more to learn and explore.
And the most exciting discoveries are yet to come.
That's the beauty of it all. So to everyone listening, keep looking up, keep asking questions, and never stop exploring the wonders of the cosmos.
And who knows, maybe one of you will make the next big discovery.
Until next time, fellow space enthusiasts, keep your curiosity alive and your eyes on the stars.